Did you know that physics is about how things move and why things move? It was Isaac Newton who discovered the three laws of motion. He was a scientist who lived from 1642 to 1727. Let's first learn about the first law of motion. It is also called the law of inertia. It states objects will remain at rest or in uniform motion in a straight line unless acted upon by an external unbalanced force. To understand Newton's first law completely, we need to learn about inertia first. See, this is a very large sofa. What's special about it? It's stable. It is not moving. Now go ahead and try to move it. Oh, you can't. It's not willing to move. You can't move it as it is very large. Now try to move this small stone. Good. You can move it a little bit, but you had to put in a lot of effort. It was also like it didn't want to move from its original position. Even the smaller things don't want to change their positions. They don't want to move. Even a small stone takes some effort to move. This is the first rule of physics. Things like to stay where they are. No object in this universe would start moving unless some external effort is put on it. It's like all things in the world are lazy. Now the question is, if things are lazy and they don't want to move, then how does the movement happen? The answer is that there are so many things in the universe which push and pull other things and force them to shift their positions, like you force the small stone to move. But as we said earlier, that things are lazy. They would try and stop their movement as soon as the effort was removed. Well, you'll be wrong if you think like that. You'd find it very strange to accept that when a small stone was still, it wanted to stay still. But once you'd put it in motion after putting some effort, it would like to keep on moving. In reality, it would keep on moving forever and ever. But somehow it stops. But it stops not because it wants to stop. It stops moving because things in its path force it to stop. It may be due to air, or if it bumps into a tree or rough surface on the ground. But suppose there were no tree in its way, or there was no roughness on the surface, and also imagine that it does not have poles or trees in its way. The stone would never stop. It would keep on moving. It happens in outer space, where there's no air or roughness. If you kick a small stone, it'd keep on moving and would never stop. So how can we say that things are lazy? See, the small stone wanted to move forever, but it was stopped by the resistance of air, trees, or roughness of surface. It's like you moving on a slippery road. You'd keep on moving unless there was some effort put in to stop you. The same is true with the small stone in outer space. It would keep moving, as nothing came in its way. It also doesn't want to stop, as it is too lazy to do that. So now we can change the first rule of physics. Things want to stay in the position they are, to things want to keep doing what they're already doing. If things are at rest, they want to stay at rest. And if things are moving, they want to keep moving. In other words, things are lazy. So there's a lot of laziness in the universe. Physicists have a special name for this laziness. It is known as inertia. So now you understand Newton's first law of motion. Can you write it? Well, you are very much right. Now let's move on to Newton's second law. As we know from the first law that to overcome the inertia of an object, we have to apply unbalanced force. Newton's second law talks about how fast an object would move. Well, it states acceleration of an object depends on the mass of the object and the amount of force applied. In mathematical terms, Newton's second law states that force is the product of mass and acceleration. To cause an object to accelerate or speed up, a force must be applied. The more force you apply, the quicker you accelerate. Look at these two swings. If you apply the same force on both swings, check whose goes faster. Let's first push the little kid. See? It goes very high. Now push this fat man with the same force. See, it does not go far, because it has more mass than the little kid. So the more mass there is, the force required to push the object is also greater. Let's look at the mathematical formula of the second law again. It's the product of mass and acceleration. We've already learned that if there's more mass in an object, to move it, we need more force. Now let's see this kid sitting in the swing. If we apply little force, then it goes a small distance. Now if we apply a lot more force, it goes very high. So to get more acceleration, we need to apply higher force. So now you can understand the relation among force, mass, and acceleration. Until now, we've only learned the first and second laws of motion. Oh, you're riding a bicycle. Have you ever wondered why a bicycle moves forward? Ah, Well, it moves according to Newton's third law, which says that for every action, there is an equal and opposite reaction. To understand this, see what happens when you drop a tennis ball. As the tennis ball hits the floor, it causes a downward force on the floor. This is the action. The floor reacts by pushing on the ball with the same force, but in the opposite direction. Action, reaction. Together, the floor and the ball form what's called the action-reaction pair. So now how it applies to your bicycle. When you push the pedal, the parts of the tire which touch the ground push it backwards. The ground also pushes the tires forward with the same force. So the parts of tires and earth form a pair of action and reaction. So what happens to the earth when your tires are applying force to push it backwards? Huh? Oh, nothing happens to it since the earth is very big as compared to your bicycle. The force applied by your tires does not move it backwards, but force applied by the earth pushes your bicycle forward. So now you understand Newton's third law. Yep, the tennis ball is the right example. The ball and the floor are creating a pair of action and reaction.